Hello, my name is Eli Blackburn, and this is Baron Hobson, Dawson Worthington, and Etienne Zambrana. And this is our study on the regulation on the use of AI predictive models in Georgia's pavement maintenance programs and our recommendations on applicable policy. There are over 88,000 miles of paved road across the state of Georgia. This pavement is exposed to many forces which ultimately cause major damage to the paved surface. Currently, GDOT standard practice is to annually drive across the state observing damage and logging the state of the pavement manually into the COPACES system, which allows for GDOT to schedule maintenance efficiently with a big picture view. Recently, AI predictive models have made waves as major innovations for many different industries. An AI model that predicts Georgia's pavement condition could have similar impacts. By reviewing expenditures from Henry County as a baseline, AI could potentially be used to save upwards of $2 million in taxpayer money every year by reducing the need for manual observation. Comprehensive guidelines would allow for confident use of these powerful new technologies.
The National Institute of Health has already created guidelines for the use of AI predictive models in healthcare. These guidelines were the starting point for our own 8-stage policy guiding the use of AI models. Stage 1 of our guidelines is to clarify the desired output of the model. In this example, it is what is the most likely condition of a given stretch of paved roadway. The output condition can then be rated on the Pavement Condition Index in accordance with ASTM 6433. Stage 2 is selecting appropriate predictors. These would be the specific results the AI is trying to predict. For example, they would be condition indicators such as potholes or cracks. The model would also have to account for variables such as weather and increased traffic.
Stage 3 is selecting relevant data sets. It will be best to use COPACES as limiting data sets for AI development to GDOT data sets, ensuring that the output will be relevant to Georgia. Step 4 is to then develop the AI itself. Supervised learning, reinforcement learning, and deep learning are all AI development methods which must be weighed in relation to each unique use. Stage 5 is validating the model. Now that the model is developed, its predictive accuracy must be reassessed using a validation data set known as internal validation, and again in a completely new unseen data set, also called externally validated, ideally from another site. Stage 6 is interpreting the model's predictions. Statistical analysis techniques such as root mean squared and other error analysis will ensure that the model operates within acceptable error parameters.
Stage 7 is then maintaining the model itself. Any updates to the model could possibly harm itself, like quality feedback loop between multiple AI models that will degrade the quality. And then finally, stage 8 is to track the ongoing impact of the model to ensure it's working as intended and is still needed in its original form. The goals of this policy are not to discourage the use of AI in pavement maintenance, but rather to provide guidance on how to best use these new and powerful tools. The attitude of the policy is to keep the use of AI as a measured solution and to dissuade the concept of AI as a quick fix solution in the face of great excitement for these new innovations.
Yet no policy is perfect. As AI is still an emerging technology, the strengths and weaknesses of it are constantly changing. With this in mind, it is important that such guidelines are constantly reevaluated for efficacy so that the best guide to use these tools are available before it is needed. These are our references. Thank you very much.